This is Algebra 2 for the practice quiz, the second quiz, I suppose. Let's jump right in. We're going to evaluate log base 2 of 16. Again, I'm thinking of this as the what power function. What power does 2 need to be raised to in order to get to 16? And again, another way of writing that is 2 to the what power, and I'll do a little arrow here, is equal to 16. Well, 2 to the power of 3, let's try that. 2 to the power of 3 is 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. Ah, darn, we were so close. We need another 2. If we multiply by another 2, then that would be 16. So how many total 2's? 1, 2, 3, 4. There are 4 of those. So the answer here is 4. The next one is saying log base 25 of 5. So 25 to the what power gives us 5. By the way, this is called the exponential form, and this is called the logarithmic form. You can change back and forth between these two if that will help you. So the hard part here is you need to go down. So if I take this to the power of 1, I would get to 25, so it needs to be a number less than 1. And indeed, you need to basically square root. So the square root of 25 will get you 5. So what's the exponential form of taking the square root? And it's 25 to the power of 1/2. These two are exactly the same. They're the same, which means I need the power of 1/2, and the answer is a 1/2. Again, don't worry about grading for any of these. Number 2, evaluate natural log of e. And this was one that was on the last quiz, so you could have just memorized it from there, or you could just walk through it slowly with me again. So natural log is really log base e, and then of e still. And again, this is now asking, let's do a little arrow here. Let's turn this into the exponential form. This is saying this e right here to the what power gives you this e right here. And e to the first power gives you e, so the answer here is 1. And this is just one of those things that I hope that you will eventually, I don't know, inscribe into that tablet that you'll leave underneath your bed every time you go to sleep. Memorize this. Have this memorized. It's a very important property of logarithms. Natural log of e is 1. Moving on to the next one, which is considerably more difficult. Log base 1/8 of 2. So this is the first time we've kind of seen this problem in my class. And again, it's asking 1/8 to what power? This whole fraction to what power will give us 2? Well, obviously we need to flip it. Right now it's upside down. So the only way to flip this is by using a negative exponent. For example, if I used -1, then that would be 8 over 1 to the positive 1. You use up the negative power in order to flip it. So we know the answer is going to be negative something. And now the problem is, how do we get from 8 to 2? And this you haven't seen before. Well, here's a cool little fact. You can take it to the power of 1/3. You can cube root it. The cube root of 8 is 2. The cube root is essentially saying what times itself 3 times, and 2 times 2 times 2, 2 times itself 3 times is 8. So the cube root of 8 is 2. And you might say, well, Mr. Sandell, that doesn't really help me because I can't take the cube root. I need a power. This is again asking me for what negative power here do I need? And the answer is, well, the cube root of any number, x, is really that same x to the power of 1/3, in the same way that the square root of any number, let's just say x, is equal to x to the 1/2. And you can probably put the pattern together. What if I do the 4th root of x? The 4th root of x is x to the power of 1/4. So the answer here is actually negative 1/3. There's another way to think about this, but I think it's too confusing. So if you want to see a second way, ask me later in class. Number 3, evaluate. All right, so when I don't have a base here, you assume that the base is 10, so it's log base 10. 10 to the what power gives you 1,000,000. And whenever you have these logarithms that are, I don't want to say natural, but the default, I should say, you just have to count the number of zeros. 1, 2, 3, 4, 5, 6, and the answer here is 6. And this is, again, one from our quiz, I think verbatim. It was even B last time. 10 to the what power is 1? Well, how many zeros do you count after that 1? I don't count any. So the answer here is 0. And this is a property that you should have memorized as well. There's 2 things that you should really have memorized. Log of 1 is equal to 0. Natural log of e is equal to 1. And by the way, natural log of 1, any logarithm with any base, is always going to be 0. So I'll put both of those down if you want to memorize those. And this rule up here, I should restate, it only works if the starting number starts with 1 and then there are zeros afterwards. If the starting number was 3, then this would not work. Moving on to number 4. If log of some number x is between 5 and 6, I just changed these bounds from the last quiz, circle all possible values of x. And again, this is a little bit misleading because there's only going to be one of these that will work. All right, so again, I'm kind of thinking of this of changing all of these to zeros. Now this is 1, 0, comma, 0, 0, 0. This is 10,000. All right, well, if I took log of this number, how many zeros are there? 1, 2, 3, 4. So this would be a number a little bit bigger than 4. So 4, and I'll say, kind of just right here, bigger than 4, because these numbers were a little bit bigger than 0. And it definitely has to be less than 5, because this is not 5 numbers after the 1 at the beginning. What about for b? Again, I'm going to cross off all of these. Think of this as 0, 0, 0, 0, 0 with a 1. And how many zeros do we have? 1, 2, 3, 4, 5. This is going to be a little bit bigger than 5. Bigger than 5. And that's what we're looking for. We're looking for something that's between 5 and 6, which means a number bigger than 5. That is the only correct answer. And again, this one is slightly bigger than 6, and this one is bigger than 7. Double quotes just means copy the previous line. And bigger than 6 is obviously outside of this range. It's somewhere out here. Don't want to explain that too much. I think you guys can get that. Again, if there's any confusion, please ask me when I'm back in person. Number 5. Because calculators can only find logs with base 10, how would you do this one? And essentially, I'm just asking for the change of base formula again. So hopefully you chose log base 10 because that's what calculators can do. You don't have to write it, but if you want to, you can say log base 10. I'm not going to write mine. And it's going to be log of the inside, log of 11, all of this divided by log of the base, log of 5. And that's all I'm looking for. Number 6, very similar. Whenever you add logarithms, you're going to multiply their power. So this is going to be 7 times 9, which is just 63. So this is going to be log of 63. And similarly, when you subtract, you do the reverse of multiply. You divide. You divide 50 divided by 40. And you can divide the top amount by 10, get rid of the 0, and that's just 5/4. So 5/4, and I'm going to rewrite the 5/4 in here. That's our final answer. You can have fraction, it's fine. You can have it as a decimal. That could have been 1.25. I'm fine with both. But again, you should not be using calculators anywhere on here. I think I said at the top, no calculators, right? Yeah, no calculator. Triple exclamation point. That's a lot of exclamation points. Number 7, solve for x. Do not use a calculator. You shouldn't use a calculator anywhere on this test. All right, the problem again is the x is trapped in the exponent. The only way to untrap it is to take the log of both sides. If I take the log, and you get to choose the base here. I'm going to leave that blank for now. Of 10 to the power of x. If I do that to the left-hand side, I must do it to the right-hand side as well. So it's going to be the log of that same base of 7. And you want to choose the base so that matches this base because the properties work out really nice. I'll go kind of slow through 7, then I'll go faster through 8, 9, and 10. So if you choose the base to be 10, then you'll have, by the way, whenever you take the logarithm, the x is allowed to come down in front. That's one of the cool properties. So you have x times log base 10 of 10. And I know you say, Mr. Sindel, you don't have to rewrite the 10 down here. By default, it's 10. I'm doing it for illustration purposes so you can really see what's going on. And on the right-hand side, I will just write log of 7. Yeah, it's log base 10 of 7, but I don't have to write the base 10. Over here, this is asking 10 to the what power is 10? 10 to the what power is 10? Well, 10 to the first power is 10. So this whole thing, the what power evaluates to just 1. And 1 times x is x, which means I have x is equal to log of 7. And there's our final answer. We could box it. And that's the reason that you always want to choose these two to be the same number, because it always makes this power go to 1, and it basically cancels it all out. All right, number 8. Again, I'm just twisting the numbers around a little bit from the last quiz, so this should look really familiar. First, I need to get rid of this 2, and then I can untrap this exponent. So I'm going to divide both sides by 2 and both sides by 2. I purposely gave you a number that didn't come out nice, and that's okay. E to the negative x is equal to, you can call this a fraction, 15 over 2. I'm pretty sure a lot of us want to say like a decimal, 7.5. It doesn't matter. You could have just left it 15 halves. And then I need to untrap the exponent. What am I going to do to both sides? And I'm going to, I want to move this out to the right-hand side here so I can have room to write my logarithm. I'm going to choose log of any base down here. I'm going to choose base e, so these two match. And you're right, you could have just written natural log instead of log base e. So I'm going to say natural log over here on the right hand side. That's the same thing. I took log base e of both sides. When you do that, the negative x, this whole negative x, comes down in front, and then this all cancels out, so you're just left with the negative x on the left hand side. And on the right hand side, you have natural log of 7.5 or 15 halves, whatever you prefer. And I'm still not done because I haven't solved for x. I've solved for negative x. So I need to get rid of that negative. You can divide both sides by a negative, but I prefer multiplying by a negative one. They're both basically the same thing. It's essentially saying change the sign of both sides. Change the sign over here to a positive x. Change the sign over here to a negative natural log of, I was about to say x, no, 7.5 or 15 halves, whatever you want. And there is our final answer. Number 9, just adding on more steps, and then 10 has a ton of steps. Again, try to isolate everything. Try to isolate right here, and then you can take the log base 6 of both sides. So first I'm going to add that 5 to both sides, add the 5 to both sides. When you do that, I have negative 6 to the power of 5x is equal to, okay, I have a negative 3 here. All right, so I still have this negative to deal with because you can't take the natural log or log of anything when it's negative. Log base of anything, I should say. So I'm going to go ahead and switch the signs by essentially multiplying by negative 1 on both sides, multiplying by negative 1. I now have a 6 to the 5x is equal to a positive 3. Both sides are positive, which means I can take the logarithm both sides. I'm going to, yeah, I totally forgot to move this over to make room to write my logarithm. You come over here, thank you. I'm going to take the log base what? Yes, that base is 6, so this is going to be a base of 6 as well, and this is going to be a log base 6 as well. You have to do the same thing to the left and right side of the equation. This 5x will come down in front, so I have 5x. And then log base 6 of 6, that all cancels out, and I'm just left with the 5x. And then I have log base 6 of 3. You can change the base here to make this into the fraction like you saw in problem number, what was it, like 5 or whatever. I'm essentially saying you can do this change of base formula if you want, but I'm never going to. I'm just going to leave it log base 6 of 3. If you don't have to do extra work, don't do it, right? Divide both sides by 5 to isolate for x. Divide both sides by 5. You're gone. X. Our final answer is log base 6 of 3. All of this divided by 5. Box it. Ooh, bad box, whatever. All right, and our penultimate challenge, number 10. Let's go. Again, we're trying to isolate this piece right here that has the variable trapped in the exponent, and then we're going to take the log base 7 of both sides. First, I have to get rid of this 2 and negative 5. Which one do I do first? Well, I'm going to just subtract that 2. Subtract the 2. You're doing reverse PEMDAS. So if I subtract the 2, I have negative 5 times 7 to the power of 3x minus 2 is all equal to, okay, I'm negative 48, and I go even more negative, so it's negative 50. All right, I still have to get rid of that negative 5, and it's being multiplied by all of this, so the inverse operation, if you will, of multiply by negative 5 is to divide by negative 5. Divide by negative 5. When you do that, you're gone, and I'm left with 7 to the power of 3x minus 2 is equal to 10. Negative divided by negative is a positive, and 50 divided by 5 is 10. All right, we're getting close, guys. And, oh my gosh, yet again, Mr. Sindel did not give himself room. U10. Why is it not grabbing? There we go. Come over here. I'm going to take the log base, yep, that's 7 of both sides. Log base 7 of the left side, log base 7 of the right side. When you do that, this 3x minus 2, this whole 3x minus 2, let me circle it, that whole thing comes down in front, and you have this quantity of 3x minus 2. That's supposed to be a minus sign. And that's going to be times all this stuff, and log base 7 of 7 is just times 1. So I guess I didn't really need parentheses there. And on the right hand side, I still have that log base 7 of 10. Moving down a little bit. All right, and then just got to solve. I have 2 more steps. I'm going to add the 2, so plus 2 to both sides, plus 2. And again, you do not say that this is 12. Please, please, please don't do that. That's trapped inside the parentheses, and then you add the 2. So I have to rewrite. I don't know why I did a line right there. Those are gone. Yes, you have a 3x on the left-hand side of our equation. On the right-hand side, we have a log base 7 of 10, and then we add 2, plus 2, outside the parentheses. Finally, divide by 3. divide by 3, and we have x isolated. X is equal to that thing. Can I just copy paste? I'm getting lazy here in my old age. Mr. Sindel, you're only 29. Why is it not copying? Grab you. Yes. Command C, Command V. Yes. And there is our final answer, and I will go ahead and box it. Yoink, yoink, yoink. Woohoo! All right. That was the quiz for, or I guess the practice quiz for Algebra 2. If you guys have any questions, please ask me when I'm back in person. And with that, I will see you guys later.